Let's take this problem from the chapter of Newton's laws of motion. Problem says two blocks of equal mass m are tied to each other through a light string. So let's consider that on a plane surface like this, there are two blocks. Another is this. And it says both of equal mass m. So this is mass m. This is also mass m. Let's consider this is block A and say this is block. It is connected with a light string. Then it says one of the blocks is pulled along the line joining them with a constant force F. Let us say this block is constant force F. Find the tension in the string joining the blocks. So if there is a tension here, there is a tension here in the string. So what is this tension? This is the question. The question is not at all difficult, but this is the first question of Newton's laws of motion. So we have taken an easy question rather, right? So to start with, let's consider both blocks and a string as a combined free body. So consider both blocks and the string as a combined and let us say both of them are moving with the acceleration A. Obviously, since both of them are tied together, the acceleration of both of them will be same. If both of them are moving with the same, in that case, we know by Newton's laws of motion, force F is equal to total mass of them is 2m into acceleration A. From here we find A is equal to F by 2. Now consider only block D as the free body. If you consider only block D as a free body, then what you find? This is the block D has a force F pulling it, and if it has a tension T pulling it back, and it is moving with an acceleration A, and its mass is M. So in that case, what do you get? This force F, that is the force towards the acceleration, minus the force T backward, is equal to its mass into A. Now, what is A? From this equation, we find A is equal to M and A is equal to F by 2M. So this is equal to F by 2. Therefore, tension T is equal to F minus F by 2 is equal to F. is the answer. Tension T is equal to F by 2, the force F by 2. Okay. Now let's go to the next problem. Let's go to this problem. This problem says that raindrops of radius 1 mm and mass 4 milligram are falling at a speed of 30 meters per second on the head of a bald person. Right? Let us consider this is the bald person's head. This is the bald person's head. And raindrops are falling. And raindrops are falling on him. And each raindrop, is radius r 1 mm. Radius r is 1 mm, which is equal to, we go to MKS system, it is 10 to the power, it is 3 meter. Its mass is 4 milligram, which is equal to 4 into minus 3 gram, which is equal to 4. And this raindrop is falling at a speed of E is equal to 30, rather U is equal to 30 meter per second. Now the question, read the question carefully. The drops splash on the head and come to rest. Assuming equivalently that the drops cover a distance equal to their radii on the head. That means, let us take the raindrop like this. That means the raindrop falls like this. The drop falls like this. And that raindrop covers a distance equal to its radius. So half of the raindrop goes, that means a dimple is created on the bald head and the raindrop goes into this. So a kind of a dimple is created on the bald head. So obviously this will create a force on the head. So they want you to find out, estimate the force exerted by each drop on the head. Here also, the question is not at all difficult. So when the raindrop falls on it, it says that initial velocity of the raindrop is 30 meters per second. This clear. And when the raindrop comes to rest, then final velocity of the raindrop is 0. And raindrop covers the distance of its radius. So S is equal to radius, which is equal to 10 to the power minus 3 meter. 10 to the power minus 3. Then we use the simple formula, V square equal to U square minus 2 alpha S. Alpha is the acceleration. Right? 2 alpha S. Alpha is the acceleration of the raindrop. Here it is retardation of the raindrop. So it is negative, minus. So what we find that V is equal to 0, E is equal to 30 square minus 2 into alpha. S is your 10 to the power minus 3. 10 to the power minus. From here, you can find out this you can work out at your home. Acceleration or retardation is 45 into 10 to the power 4 meter per second square. So now we have the retardation of the raindrop, and we know mass of the raindrop also. So force exerted or retarding force exerted on the raindrop by the belt head is equal to force is equal to mass into retardation or acceleration is equal to mass is 4 multiplied by 10 to the power minus 6 multiplied by, we have here 45 into 20 to the 4. Once again, you calculate this, this will be 1.8 Newton. So the force applied by the raindrop on the belt head is 1.8 Newton. Now we shall go to next problem. Next problem, similarly, it's not a difficult problem, but like all others, my advice to all students is first think about the problem properly before starting to work out, because it is sin that always 3/4 of the time you need to understand the problem and plan to solution, and only 1/4 of the time is required to solve the problem. This problem says a man has fallen into a ditch like this, like it is shown here. A man has fallen into a ditch, and two of his friends are trying to pull him out with the help of a pulley. This is the pulley. With the help of a pulley, he is trying to help him out. Show that the force exerted by each friend on the rope increases as the man goes up. Shows that as the man is lifted up, the force exerted by each of his friends is more and more. Then there is the second part of the question, which we shall see later on. Now, here, once again, if you think about the problem, see, let us draw a schematic diagram. Let's say this is the mass of the, this is the mass of the man. Let us say this is the mass of the man M at his center of gravity. And so obviously the force downward is mg. And see, there are ropes like this. There are two ropes like this. And there is a pulley. There is a tension. And it is said that both of these are identical. It is also said that the distance between these two pulleys, T, distance which is given here, distance between these two pulleys is T. Now, if this force is tension, if this is tension T, so this is T. If this is T, they are equal. This is T. And let's say this is the triangle, and this is a line joining them. And say this angle is theta, so this angle is also theta, since they are same. Now, if this is force T, then what is its component? Vertical component is T cos theta. That means the line by which So vertical component of T is equal to yeah. So total force by the two friends. So total force by two. So this total force will be equal to mg. So this will be equal to m. From here we find equal to mg divided by 2 cos theta. So force exerted by each friend is equal to mg by 2 cos theta. Now what happens? As the man goes up, as as the man is up, what do you find? If the man is pulled up here, if the man is pulled up here, then the new angle will be like this. So theta will be more. As the man is pulled up, theta increases. Theta increases, that means cos theta decreases. Now look at this here, cos theta is in the denominator. So if cos theta keeps on decreasing, then the value of t will increase. So t will, that means as the man is pulled up, the force exerted by each friend will be more and more. Now there is a second question here. Find the force when the man is at a depth of h. So let us consider this is the depth of h. We have to find out the force. So force is known. So we only have to find out h, cos theta in terms of h, right? So this is h and this is d. So this much is d by 2. So in that case, let us say this is c, this is a, and this is b. We have to find out what is AC. AC, we find here, AC is equal to the root of d by 2 whole square, that means d square by 4 plus h square. And cos theta is equal to base by the hypotenuse. Base is cos theta equal to h divided by this whole thing. That means d square by 4 plus h square whole under. This is equal to h, and work out here. This is d square plus 4 h divided by 4. This 4 under root is 2, it will come upward. So it is 2h divided by d square plus 4. So this is cos theta. So cos theta is known. So the tension T will be equal to mg by, and that divided by cos theta. That means we have multiplied by 2h here and d square plus 4 square here. So this is equal to mg by 4h multiplied by whole under root d square plus 4h square. So this is the answer to the second part of the question. So here we have shown three problems. Next we shall take another few